Okay. So this first chapter is just kind of giving you the intro to what statistics is, right? So these are kind of sections. We'll talk about statistical critical thinking, right? Types of data. Then, right, if you know types of data, how do you actually get data, right? You won't actually be doing that much in this class, but you'll be thinking, you might be asked questions about how other people get data. And then 1.4 we'll probably not get to today. That's using Excel. So your laptop, I always write tomorrow, but I really mean the next class, my bad. So bring your laptop to class. Yeah, and try to make sure that it has some sort of Excel on it. This first chapter goes by fast because there's not really a lot of calculations. It's just understanding some things. So first is section 1.1. And again, I recommend reading the textbook, right? And I will show you again how to access that online on Wednesday. Because everything, it was very close to it. So if you missed it when I was talking, you zoned out, it will be in the book, right? And it will strengthen it with more. I can't read the whole book in class, right? So it will strengthen it with extra examples, stuff like that. Okay, so one thing that you want to know is, okay, Mr. Neff, you said a whole bunch of stuff, but how much of that stuff was important, right? These are the learning objectives. So at the end of section 1.1, I expect you to be able to do all of these things, right? So that's another thing, right? It's a lot to write these down right now, but when you're looking back, right, when you're studying, go to each PowerPoint, see what the learning objectives are. Do you know how to do them? Do you even understand what they mean, right? Then that's a good time to review that. So we're going to talk about the differences between population and sample. So you should be able to identify which is which in a story, right? We're going to talk about significance, both statistical and practical. We're going to talk about voluntary response, right? We're going to look at bias in data collection. We're going to talk about the difference between correlation and causation, and we're going to describe the purpose of a statistical study. That's a lot, but these things, there's not a lot of calculations, so we can kind of get through this stuff fairly quickly. Okay, so there's different steps that we can think about when you are doing statistics, right? Roughly speaking, the process is to prepare, analyze, and then make some sort of conclusion if possible. Sometimes your conclusion is no conclusion is possible, which, I mean, that's probably disappointing if you were doing it, but that's just the way life works sometimes, right? So so you will learn how to do calculations, right, in this class, but none of them are too complicated, right? And this is a business statistics class, so none of you will probably be statisticians, right, or have a job that involves doing a lot of statistics. Now, you might honestly be able to do some statistics, right? If you're in marketing, anyone's studying marketing here? Okay, kind of, you might need to know when your boss says, how did your marketing campaign go, right? Okay, so you know, now 27% of people buy the product when they see the ad. Before it was 23. Is that different significance, or is that by chance? You might actually do some statistics, but most of you will be interpreting statistics exclusively outside of this class, right? So we're going to focus on that. That's what I want you to get out of this. Important definition. So data is simply a collection of observations. They can be measurements, right? I could measure everyone's height, write all that down. That would be a data, right? That'd be numerical, but it also could just be responses. What gender are you, right? Or your responses to a survey. That's what I'm doing. I'm collecting data from y'all in the Get to Know You survey. Again, try not to write down everything. Remember, all of this is posted online. Also, I'm not a big fan of asking, I'm not a big fan of definition questions. So I will not ask you to define statistics and have to write something like this, right? I want you to get the general idea out of it. Trust me, I don't even want to grade that, right? Yeah, right. So statistics is the science of doing studies and experiments, obtaining the data, organizing it, summarizing it, analyzing it, and interpreting it, and getting conclusions. So statistics is a science, right? Which means more so than math in some ways. So here's the main idea, right? So a population is the collection of all measurements or all the data that's being considered. Typically, a population is a complete collection of data we would like to make inferences about. Sometimes the population is very large. For example, all Americans, right? If you are trying to market for, right, if you are a marketing professional and you work for NBC, you might want to know who, okay, right, we sell Peacock, we sell streaming services are available anywhere in America, so that's our population we're interested in. Right now, oftentimes the population is too big to get data from the whole population. It'd be very difficult for me to find out how many hours of what exact percentage of America have seen the show The Office, right? It'd be much easier. Now, if the whole population I was considering was just this class, that's easy, right? So the population oftentimes is very large. So census versus sample, right? So a couple years ago, does anyone remember that you got like a census form at your house, right? And you filled it out. It's called a census because everybody got the form, right? So a census is a collection of data from every member of the population, right? And it's typically very difficult to do, but sometimes you can get it, right? Like there are a lot of students here. I could get a census of how many credit hours every student here earned last semester. A sample is much more typically collected. It is a sub-collection, right, of some of the members, right? So when they call you and say, who are you voting for in the upcoming election, right? We have a presidential election this year. That is a sample. But they're more interested in what's the whole population going to do, right? So a big part of statistics is how do you make inferences from a sample to the whole population? Now, that is called inferential statistics. That's what we're going to do in the second half of this course. At the beginning, it's more like descriptive statistics. How would you describe a sample, or how would you describe a population? Oh, here's an example, right? I want to know, I have a feeling, right? They say, I replaced my carbon monoxide detector a while ago. It says check it every 6 months. I doubt almost anybody actually remembers to check it every 6 months, right? So you might be interested in how many carbon monoxide detectors are actually effective, right? There are a lot in the United States. You can't test all of them, so you just test 30, right? Whether that 30 is representative of the 38 million, statistics can help you with, right? So we'll actually learn about that. So here's kind of the process. You can read this. I definitely suggest going to the book, right? You prepare. What do you want to know? Where are you going to get data from? What method will you use? Okay, now you have the data. Can you analyze it? First, you might just be presenting the data. How do you graph it? What are some statistical methods that you can do? Can you find the mean? Can you find the mode? Then you use conclusion. A lot of times we'll use technology, right? And then what are the significance of this event? Questions so far? I know I'm just kind of throwing a lot of stuff at you. So here's an example, right? So this is data, right? These might be data from particular years in Florida, right? So those are the number of pleasure boats that are out in that year. And then down there in tens of thousands. And then these are how many, I don't know why the textbook used this, it's pretty sad. This is manatee fatalities from them hitting propellers of boats and whatnot, right? So is there a correlation between the two? That might be it. So the context would be understanding what the table is. You format the table since it's paired data. They're trying to see whether there is a relationship, right, and how that relationship could be characterized between the two variables. Want to consider the source of the data, right? So this data is from a government source, right? So that's usually more reputable than if it's privately collected data, which might have some sort of bias. We don't know the sampling method, but typically sampling methods are reliable when they're used for government purposes. That's a reliable sample. One of the biggest, you're actually going to learn a lot in this class, right? And if it weren't for this one thing, right, this class might be all the statistics the world would need, right? You would learn, if it weren't for the voluntary response problem, you would learn enough statistics that you yourself could be a pollster if you get a B in this class. I'm not kidding, right? But you're not going to be able to because there's a lot of methods to get around this. The voluntary response sample, anytime you are having people in your sample, right? It's a free country, it's a free world. People don't have to be in the sample, right? Anybody here ever been called on their cell phone or their home phone for a poll? Did anybody do it? Or most, no, right? So that's the other thing. So you can look at the people who did it, but those people are likely to be different than the people who didn't do it in some way, right? So that's an issue. Just because 30, so for example, if you have, I don't know, a lot of people probably feel like maybe people who are bored are going to definitely be oversampled, right? People have less things to do. Older people, you hear, oh, right, we're trying to get people's opinion on instant replay in sports, and you have a strong opinion on that, you're going to want to take that survey, right? If you don't follow sports, right, you're a casual fan, maybe you don't answer the questions. So these are so any of these things where people self-select in or out of the sample has a strong possibility of bias, right? So one example is internet polls, because like, especially this, because like, I don't know, you have an internet poll, you post it on your Twitter, right? Like sort of people who are like that might be your age, right? It's definitely not going to be representative of the sample. Mail-in polls where they send you a postcard, right? People have to spend the time. Again, same thing. Same thing with telephone call-in polls. There's really no way to get around this, like to have this not happen, right? So that's what a lot of pollsters do, is they try to find ways to work around this, right? If you didn't have to work around this class would pretty much teach you almost everything you need to know, right? So this is something that they definitely shouldn't have done, but there is this drug many years ago that was supposedly supposed to help you choose the gender of your child, right? So if you took this drug, it was supposed to help you have a girl instead of a boy, right? I don't know if this is a real story, but this gives you, it's going to illustrate the difference between statistical significance and practical significance. So let's say this was given to 10,000 couples, right? And 5,200 of them had a girl. That is close to half, but it's more than half, right? You'll learn how to figure this out later, right? So the probability that if you had just, a random sample of 10,000 births, the probability that more than 5,200 of them would be girls, right? If the chance really is 50-50, is 0.003, right? You might say it doesn't seem that different than 50%, but since there's so many, it's enough to know that the probability is higher than 50%, right? So statistically, this is an example of statistical significance. This drug increased the probability of having a girl above 50%, right? At a high certainty, because this event is very unlikely to occur by chance. Everyone kind of following? But it's not very practically significant because it raised the probability from 50 to 52, right? I don't know if you think this is ethical or not, but whatever you want to think about it, right? If you really want a girl and they said, we got this drug and we can guarantee it will raise the probability of you having a girl by 2%, whatever, right? But there's an effect. It's small, but they're statistically, as certain as you can be statistically, that the effect is caused by the drug, right? So does everyone see that there is statistical significance? There are two things that are different, and we're sure that didn't happen by chance, That's statistical significance. Practical significance is, what can we use this for? And the answer is not much, right? Do we get the difference here? So we're sure it increased it from 50 to 52, but that is not a big enough difference that we care about it. So one is so this is statistically significant, but not practically significant. We all following? Okay. Getting enough head nods, glad to see that. Pitfalls, making misleading conclusions. Sample dated, reported, not measured. People often have this. If I just asked everybody what their weight was, I'm pretty sure I'd get a different mean than if we actually weighed everybody, right? Loaded questions. Sir, is it true that you have stopped beating your wife, right? Like that's not, there's no good answer to that question, right? Order of questions, right? If I ask you to rate a whole bunch of things on the scale of 1 to 5, that 100th question, people are tired, they're probably barely reading the questions at that point, right? So non-response, percentages. So there's next section is less random, but it's a little tricky. We're going to learn about the different types of data, which also is about the different types of measurements. So let's think a little bit about this, right? We're going to distinguish between parameters and statistics, different types of data, and determine when particular statistical calculations are appropriate to do. Okay, so parameters versus statistics. This is fairly straightforward, but students sometimes get this wrong. So the main idea, right, is, oops, there's a typo here. Okay. This was in here last year and I still didn't fix the typo. That's bad. But I never remember because like I find the typo in the middle of the class, right? And then I check later. Okay. So a parameter describes a population and a statistic is for not a population, but a sample, right? Now, what a population is and what a sample is depends on what you're thinking about. So I could measure everyone's height in this classroom, right? And then get a mean, right? I could find the mean height of this classroom, the average height. And that would be a statistic if I'm interested in if the whole population is all of SXU, right? Because it is the mean of part of the population, right? If I somehow collected the height of everybody at SXU and averaged them, that would be a parameter, right? Or if you think about it, right, if there's going to be an election in November, right, I call people, right, 51% of my respondents say they are voting for Joe Biden, right? That might be different than the population percentage. How different is what we're interested in, right? So it's very difficult to figure out how people are going to vote until you actually vote, right? So typically, right, if the population is very large, it's impossible to calculate a parameter exactly. So typically you get a statistic to estimate a parameter, right? So most things that you read are statistics, but they're kind of written as if it's a parameter, right? So you might read 30% of Americans were born in a different state than they live in now or something, right? Did they actually ask everybody? No, right? But they're trying to conclude it for everybody. So they collected a statistic and they're using it to estimate a parameter, right? So key point, parameter is everybody. Statistic is a sample, right? Basically, the purpose of any statistical study is to get some sort of statistic to estimate a parameter, right? And there are better ways to do this. And you can imagine some ways to do it, right? If I wanted to estimate the mean height of Americans, I would want to get a sample, right? A bigger sample is better than a smaller one, but a more representative sample is more important, right? If I collected everybody at XXU, that might not be the best sample for all of America, right? Because y'all are young, right? This class, XU, is more diverse racially than all of America, right? So some racial groups like Hispanics would probably be overmeasured, right? So that might affect the height. So you want a representative sample, right? So that's the difference between parameters and statistics. Questions here. So, and you can match the letters. Parameter starts with a, I'm actually just noticing this right now, P, and a parameter is a measurement for a population. So P with P, statistics are with samples, S and S. Data can be quantitative or not. So quantitative data is typically what we think about with data. So it is data that has a number that corresponds to a measurement of something. For example, right, I could go find some, well, I couldn't, but somebody could find some supermodels and collect their weights, right? That would be an example of quantitative data. The ages of people who respond to this poll, that's quantitative. Now, a lot of people shorten it to quantitative is numerical data, but that's not always true, right? It has to, of course, the number has to be meaningful in some way other than being an identifier. For example, on a football team, right? Everybody, each player has a number, right? Anyone have a favorite athlete? Okay, so Aaron Rodgers, and he wears 12 on his jersey, right? So Aaron Rodgers has a 12, but does that 12 correspond to 12 of something? No. So that 12, while you might say, okay, so if I collected all the jersey numbers from the Green Bay Packers, or Jets now, right? That would not be numerical, that would not be quantitative data, because while those are numbers that are not measurements of anything. Right? Does everyone kind of understand that? Another example would be our social security numbers, student numbers, right? Those are numbers, but they don't measure anything, right? So those numbers really are standing in for just placeholders, right? In an alternate universe, instead of having numbers on jerseys, players might have different shapes, right? And it would serve the same purpose, correct? So in that case, categorical data. These are things that are labels that are not numbers that cannot be ordered in a specific way, right? So gender of individuals, favorite colors of individuals, names of individuals, or shirt numbers on professional athlete uniforms, right? Even though those are numbers, the numbers are standing in for a name. This is called categorical data. So quantitative data has to be a number, and then the number has to be measuring something. So something that is an identification number, a number that could stand in for a name, is not numerical data. So you're gonna, in your homework assignment when you log on, right, these take a while. You're gonna be doing a lot of questions. These will not be a lot of calculations. They'll give you some sort of question and then say, is this an example of categorical data? Is this an example of numerical data? When you're talking, now this is only for numerical data, right? When you have something that is numerical, it can be broken down between discrete and continuous, right? So discrete data is data where the number of values is either finite or countable, right? So typically it's something that has to be a whole number, right? So for example, the number of tosses, so I could toss a quarter over and over again, right? And then write each time how many flips it takes me to get a heads, right? So maybe the first time it's 2, then it's 3. Maybe something very unusual happens and it's 10. There's no limit for how many times I might have to flip that coin before getting ahead. But it's still countable and is in the numbers you would get there by counting. Right? And the sort of the answer is not going to be 4.5, right? 4.7. I have to flip a coin a full number of times. Continuous data is when there are infinitely many possible values between two numbers. Height is an example of continuous data, right? So how many heights are possible between 5 foot and 6 foot? Well, there's infinitely many, right? Because even if you say, well, 5'1", well, what about 5 foot and a half? 5 foot and a quarter, 5 foot and 3/4, right? Big thing that's kind of it, right? Discrete data typically comes from when you are counting something. The number of times an event happens, the number of states someone's visited, the number of dogs somebody has, right? Often, discrete data, there isn't a unit, right? My height in centimeters is different than my height in inches, right? But there is no equivalent of that when you talk about how many times you flip a coin, right? So these are different ways you can help distinguish between discrete and continuous data. Okay, so to give you guys a little bit of something to do, I'm going to write down, or just try to write this down. Okay, so I want you to turn and talk to somebody around you just to make sure you're on the same page. In your own words, difference between parameters and statistics, quantitative and categorical, discrete and continuous. Does everyone understand what I'm asking you to discuss? Yeah, so I'm going to walk around and listen to you guys. You can check in with me. Maybe try to come up like of examples. Just go through the last 3 things, right? So parameter statistics, discrete continuous, categorical numerical. Everyone understand what you're being asked to talk about? All right, go ahead and give that a shot. If I asked people's ID, if I collected all of your ID, your student IDs, would that be numerical or categorical data? It's categorical. It's a trick because I said your student number, but your student number, right? The number itself is not significant other than it's uniquely yours, right? It's not, if your student number is 3008, that does not mean you have 3008 of something, right? So that is a categorical data. Now, if I collected asked how many credits you had at SXU, that would be an example of numerical data. But would that be discrete or continuous? Discrete, because you can't, classes, I don't know if there are any, you can't take partial credits, right? It's either 1, 2, 3, right? Everyone would have a number of credits that is a whole number, right? Or if I asked how many pets everyone had, that would definitely be another example of discrete data. Now, if I asked what's the total number of hours you spent on campus, that would be discrete or continuous. Yes, right, and it can be in between. And the other thing is, I said hours, right? But I could just as easily ask minutes or seconds. Typically, different ways to measure something means that it's a continuous set. Okay, so we get that. Now it breaks down into 4 different. This is possibly the hardest thing that you're going to learn today. So let's try to focus a little bit of time on this, and then see if we can get these right. So there are 4 levels of measurement: nominal, ordinal, and interval and ratio. And they kind of are a ranking, right? So I don't really know, there's not a word for exactly what they're ranking, but ratio is the most measurey, what does that even mean, right? But you'll kind of get it. Is the most like a measurement, to nominal, which is least like a measurement, right? So I'll give you a moment to write down those 4. And we call these levels of measurement, right? Don't worry if you don't write them all down right now, because I'm going to have 1 slide on each type, okay? So the worst type of one is the nominal level, right? And the thing that's easy about nominal is it's the same thing as categorical data, pretty much, right? So if I have data that is only categories, right? Yes or no? Names or labels, right? And if the data cannot be arranged in some order, such as low to high, that's a pretty good example. Right now, I could arrange everyone's names in here, in alphabetical order, but the order of the alphabet itself is arbitrary. I don't know how it got decided. Somebody or at some point decided that, right, B comes before C. Could easily imagine an alternate history of the world where C became before B, because why the hell not, right? Like there's no particular reason, right? So anything that cannot be arranged in a meaningful order is categorical data, right? So if I said, well, you could kind of see it, yes, no, undecided, right? Favorite, would you prefer chocolate, vanilla, or strawberry ice cream? Probably neither. It's a little too cold outside, but those would all be the nominal level, right? It's not really a measurement at all. If you're collecting nominal data, the really only thing you can do is say, okay, how many people like strawberry, how many people like vanilla, etc. Right? We good on not. I think that's probably one of the easier ones. These other ones are a little bit harder to distinguish. Ordinal, perhaps some of you who have taken some like ordinal, an ordinal number is like saying second instead of two. Has anyone heard that? Right? So ordinal level means that ordinal has the word order in it, right? So when I think of the word ordinal, I see the word order. So it is data that can be meaningfully ordered, but not necessarily the differences between levels cannot easily be determined or are meaningless. This one's not the best, but like think of course grades. At the end of this course, some of you will have A's, some of you will have B's, some of you will have C's. I'm hoping none of you have D's or F's, right? But okay, when I'm doing these examples, just let me show, I'm not implying that you will earn this grade, right? This is just so, right? So Kennedy and Ashley, let's say at the end of this course, they both get B's. And let's say, Fabian, you get an A, right? I'm just making this up right now. Now his grade is different than Ashley's, but his percentage might be closer to Ashley's than Kennedy's, even though they have the same grade, right? So you can rank, right? A is better than B, but you can't necessarily say how much better, right? The differences between the levels are not particularly interesting, right? An example, on the baseball team, right? I could take all of your team's batting averages, put them in order, and then give you a ranking. This is the player with the first highest batting average, second, third, fourth, fifth. The difference between the first and the second could easily be more than the difference between the 10th and the 20th. I don't know if that's, you have that many people on your baseball team, but you get the idea, right? If you're doing something that's a ranking, right, there might be a big difference, right? So something that you can order, but like the differences between each level, right, between each might be different or not meaningful, right? So typical things involve things that you rank things. I could ask you to rank like your favorite movies or something, right? The difference between the first and the second, in that case, you can't even tell me what I'm exactly measuring, right? What's the difference between the first and the second movie? I don't even know. It doesn't mean anything, right? So something that can be, this is the, I think, one of the harder ones. So when you're having categories where one category is better, but it's not necessarily much different, right? Another example is like income tax brackets, right? There, people within the same bracket might be earning different incomes. They're just close together, right? Two people that are in different tax brackets could have more similar incomes than two people in the same tax bracket, right? Do we kind of get these ideas? This one's a little bit harder, but it's one where the differences between levels are not consistent. Interval data is one where differences mean something. If I'm playing a game, if one player, well, that's not the best example. So years, right? What year it is, the difference between these 2 years is 10 years, right? The difference between these 2 dates is also 10 years, right? That refers to the same amount of time, right? If somebody comes first in a race, someone else comes third, and someone comes fifth, I can't say that the person who came third is as close to the person who came first as they are to the person who came fifth, right? So in that case, the difference is not meaningful. Here it is, right? A difference of 10 years is the same, right? So think about two things that are a certain number apart. If it's always the same difference means the same thing, right? That's likely that it means that it's an interval data. So differences are significant, right? But the other thing is that the 0 point has to be arbitrary. So for dates, right, we signify the year by the number, right? And 00 is when we estimate that Jesus was born, right? Roughly speaking. But you know that is, as a Western society being based on Christianity, that is an arbitrary decision, right? In other countries, they have different calendars, right? There's the Jewish calendar right now, it's the year 5000 or something, right? That's just as valid, right? But, right, the difference, you choose a 0 point arbitrarily, right? But the differences are constant, right? If it's 10 years difference in the our calendar, it has to be 10 years difference in the Jewish calendar, right? Another example is temperature, right? 10 degrees warmer than one thing is 10 degrees warmer, right? That's a specific amount, right? But we chose, right, if you're in like Celsius, right, we choose the freezing point of water to be 0. Right? Fahrenheit has a completely different 0 because when we're talking about temperature, the 0 is arbitrary. Right? If you are any dating system, you can choose any year 0, right? Or if you're choosing longitude, right? 0 degrees longitude, they decided that that should go through London, right? But they could have just as easily chose it to go through Chicago or Phoenix, right? So anything where the 0 point is arbitrary is interval. So no meaningful 0 point, no natural 0 point, but differences are meaningful. Archetype example of this is temperature. So now you can kind of see what I mean, that these things, as I go through them, they get more measuring. Nominal, you're not measuring anything at all. You're just labeling things, right? Ordinal, you are ordering, hence the word ordinal, right? But you can't really do any differences, right? There's no meaningful differences. An interval, you can both order things, right? This year is the latest. This is the second latest, third latest, fourth latest. But I can also talk about the differences between those events, right? The difference is meaningful. But there's no, so you can do subtraction here, right? Subtraction means a lot. Not so much for ordinal data, ordinal level. This is the one that is the most measuring, in my opinion. So both can things be arranged in order, differences are meaningful, and ratios, aka division, is the most meaningful. So these are things where there is a natural 0 point. So here's what I mean by that. You could have a class that's 100 minutes long. You could have a class that's 50 minutes long, right? So notice this is an example of ratio data. So notice the difference between these classes is 50 minutes, right? That is meaningful, but it is also meaningful to say that this class is twice as long, right? And you get twice by dividing 100 by 50. So that's a ratio, right? Now, it would be, wow, this wouldn't happen. If today it's definitely not happening right now. If someday it's 100 degrees and the next day it's 50 degrees, would it be meaningful to say that that second day is twice as hot as the first day? No, because in some other scale, right, that might be 60 degrees and 110 degrees, right? See, the ratio is arbitrary because right where the 0 is arbitrary. Then the differences aren't meaningful, right? Now here, the length of a class time does not have an arbitrary 0, right? 0 minutes is a class that doesn't exist, right? Has a class length of 0 minutes means something very specific, right? So here notice you can do anything. You can divide, you can subtract, you can order, right? So there's different ways of thinking about it, right? So if you want a summary, nominal is categories, right? Only. So you can kind of think of there's 3 operations you can do, right? You can order, you can subtract, and you can divide, right? I'm going to call this O, S, and D, right? But only sometimes, you always can do this, but only sometimes is it meaningful, right? So in nominal data, there is no sensible way to order, no sensible way to subtract, no sensible way to divide. There's nothing you can do. In ordinal, it suggests it. The word ordinal sounds like order, right? Interval, you can order, you can subtract, but you can't divide, right? Ratio, you can do all 3. It's tricky because some of these mean different, it's hard to come up with a lot of different examples for some of these. But they're all important. I think this is the trickiest part of this section. Any questions on what these 4 levels of measurement mean? I know, but it's a little tricky, right? So I want you guys for the last couple minutes, and I'll do some sort of warm up when we come back on these data levels, right? Just with do the same thing. You can maybe do more people since it's a little bit more complicated. Try to talk about what each of these levels are and maybe come up with some examples, and then you guys, once you're done with that, you can leave, and I'll just kind of circulate to see how you're doing. Does everyone understand what they're being asked to do? Okay, so let's just do that for a couple minutes, and then that'll be the end of class. All right, let's try to do one. All right, guys, I'm just going to try to do, so height of an individual, discrete or continuous? Because, right, you have to be, you can measure, yeah, go. Yes, and you can go in between each of the measurements, right? There's not a there's right now, tougher one, which of these 4 is the height of an individual? Well, interval means that the differences are meaningful. That's true, right? If someone is 5'2", they are 2 inches shorter than someone that's 5'4". That's the same height difference between 6 feet and 6'2". But is there a natural 0 point for height?
Wait.
Yeah, so someone, yeah, this is 0, right? So if you have a younger sibling that's 3 feet tall, right, that person would be half my height, right? That would be meaningful. So it's an example of ratio. You can do ratios of people's heights. You couldn't do ratios of someone's body temperature, right? This is tricky, so we'll do a warm-up activity with this when we come back.